All right. So yesterday we talked about how a quadratic had a line of symmetry, right?
Yeah.
So I'm going to say the graph of a quadratic is symmetric.
The graph of a quadratic.
We have not yet looked at the table of a quadratic. But that's what we're going to do today. The table of a quadratic is also symmetric.
Do we write symmetric on the
Mm-hmm. If you want to abbreviate and put those two sentences together, you're welcome to. All right. And we're going to be using the calculator quite a bit today, but I'm going to be writing things down as we go as well. So example 1, we're going to use our calculator to graph the quadratic y equals 2x squared minus 4x plus 8. And actually, I'm going to have one of you do that for me. There we go. Class, everybody. Let's see. I don't know who's my presenter.
You pick random?
Yeah, I picked random.
It's not. Is it really? I'll say.
There we go. Now we can see both. All right, I don't know who my presenter is, so I need everyone following along because I need everyone to practice. We're going to graph that function y equals 2x squared minus 4x plus 8. So add a new document. We're going to add a graphs page. Very good. So I want to point out here, I have y equals, but my table, I don't think it'll let me point over here at your calculator screen. My entry line here says f of x, right? Do I need to change that f of x to y?
Yeah. No.
No, in fact, if you change it to y, it will not let you see the table. So make sure, I'm gonna circle this and say f of x for when we graph in the calculator, okay? So let's go ahead and type in 2x squared minus 4x plus 8.
Okay, that's not me.
If you're having troubles, let me know. No. 2x squared. You need x. 2x squared. No, we don't. Totally happened.
You type it in or write it
Yeah.
down?
You're both. You're writing this down and you're graphing it in your calculator.
Did it do it right?
Oh, that looks beautiful.
How do I get the tiny x? Max is so big.
Now try it.
Is it yours?
There you go.
Oh.
You had your cap locks on.
Okay.
How do you?
Control Shift. All right. So my presenter did a beautiful job of graphing here. So
Wait, what?
your graph should look something like this. We can barely see that parabola, right? You can just see a little bit of it. So what I'm going to do is I want to take a look at the table so that maybe we can get some more information about this parabola. So how do I get to the table?
You go to menu.
You could do menu, table, table, split screen, or Control T, right? So I'm going to put that note up here.
But wait, Control T?
Control, and then T will give you the table. Hey, look at that. All right, so this is what I want to see here. So in my table, I've got all of my x's are listed on the left, and all my y's are listed on the right, yes? So I've got 6, 8, 14, 24, 38. So if we go down, those numbers are going to keep getting bigger, right? So what do you think is going to happen if I go up? They're going to get smaller. Can you go up for me, ma'am? Oh. So they got smaller and then bigger again, right? So there's symmetry in my table. So let's go ahead and in my table here in my notes, I'm going to label my table X and Y, and we're going to write down some of those points from the table. So let's see here, I'm going to do -2, -1, 0, 1, 2. So when X is -2 from the table in your calculator, when X is -2, what do you get for Y? 24.
Wait, did you put 0, 1, 2?
Yeah, 0, 1, 2. I'm going to scroll down. Sorry about that. All right. -1, my Y value is 14. 0, my Y value is 8. 1, my Y value is 6. 2, my Y value is 8. So right there, it turned. Remember yesterday we talked about how a parabola, when it was facing up, it went down and then stopped at the vertex and then turned and went back up. The same thing happened here with the X and Y values, right? My Y values decreased, stopped, and turned and increased again, right? All right, so I want us to make a prediction. Don't scroll down yet. If I had to predict, let's see here. I'm going to scoot my, there we go. If I had to predict when X is 3, what is Y? So let's look at the table here. So when I've got -1, Y is 14. When X is 0, 8. 1, 6. And it turns and goes back to 2, 8. So can we make a guess about 3? When X is 3, what is Y?
14.
14? So let's check. Go down 1. When X is 3, hey, Y is 14. It's kind of neat. All right, so just like on the parabola yesterday, the middle of that U shape, where we had the very bottom or the very top, that was my vertex, right? So the middle of my graph is where, if I look at this table? Where's the middle of that table? When Y is 6, right? Because see here, I've got 14 and 14, 8 and 8. 1, 6 is right in the middle, isn't it?
Where'd the 224 go?
It didn't go anywhere. -224.
Where would it go?
Huh?
Where would it go though?
Well, then if I went down, I could make a prediction here. If I have 4, 24, right? It's going to keep going like that. Is that better? All right, so my vertex is 1, 6. All right, so we're going to use that vertex to find my axis of symmetry. So X equals, what's the X value of my vertex?
1.
1. That's it. Better? All right. Also from my table. Remember yesterday when we said the y-intercept was 0, whatever value it crossed the y-axis at? So if I look at my table here, when X is 0, what is Y? 8. So my y-intercept is 0, 8. So there's so many things we can get just from the table, isn't there? It's beautiful. All right, and then I want to do just a quick sketch because it's a good skill to have to be able to sketch a parabola. We're going to do just a quick sketch of this parabola. I'm going to do 5, 10, 15 on the y-axis. And I'm going to count by ones on my x-axis. 5, -5. So if your spacing is off just a little bit, that's okay, because this is just a sketch. It's just a sketch. I'm going to plot some of those points we've got. So I've got -114. So that's right there below 15. 0, 8. 1, 6. 2, 8. 3, 14. And then I can just connect the dots to sketch that bowl-shaped parabola. So you're not going to have straight lines because a parabola is curved. Okay, good one. I'm about to move on to the next example. So that you're not going to have straight lines because a parabola is curved. But when it's really skinny like this one, when it's a narrow parabola, it kind of looks like straight lines, right? It almost looks like a V. That's a different function that you're going to do later. Looks good. Looks good. What do y'all think? Kind of fun even? No. Ha ha. Funny joke. Good looking parabola. Good looking parabolas. Ooh, I like how you used your lines to space out. Nicely done. Nicely done. All right. One more example together. You ready? All right. Woo! We're so excited. All right. Example number 2. Everything doesn't want to stay together today. Let's see. There we go. Example 2. Is that okay? Melina's upset with me. You okay? Oh, I thought you were mad at me. You're mad at him. Okay. That's better. So it says, what is the vertex of f of x is equal to x squared minus 20x plus 113? All right. Let's see here. I'm going to get a different volunteer. Let's see. Oh, this person looks like they're ready to help. All right. So, do you want to say no? And we're going to graph this function in your calculator. F of x is equal to x squared minus 20x plus 113. All right. Ooh, I like how my grapher, my calculator handler is graphing there. So we've got x squared, so we're going to graph this in the calculator. Minus 20x. No, 20x. Plus 113. We couldn't do 200x, that was going to be even bigger. All right, oh! And when you hit enter, can you see the graph? Not at all, right? So we would have to zoom out till we found that graph, right? That just seems like a big pain, doesn't it? I know, right? So let's see if the table can help us. So control table, right? T. Control T for your table. Oh, that's a good looking table. Children.
Adults.
Mm-hmm. All right. So let's see here in our table. Plus 113. The constant term. Sorry about that. All right. So Here we've got 94, 77, 62, 49 for our y values, right? So keep going down. Let's see if we can find where it turns. Let's see if we can find the middle, the symmetric part of this function.
17.
Oh.
There we go, right? So here I'm going to have 8, 9, 10, 11, 12. So when x is 8, y is 17. When x is 9, y is 14. When x is 10, y is 13. When x is 11, y is 14. When x is 12, y is 17. So where's the turning point? Where's the symmetric part of this table?
10, 13.
10, 13. So my vertex is located at 10, 13.